Alright, so once again, this method is called elimination because we're looking to eliminate one of the variables. Now, hopefully you've noticed, and it mentions in Canvas, that you should use this method whenever both equations are in standard form. So I'm noticing they're both in standard form because my x's and y's line up, but I've got to get one of the variables to eliminate. So as I look at this, I got to decide is the x's easier to eliminate or the y's. And I guess there's really not much difference. I could eliminate the x's, but if I added the two equations together, nothing would cancel. So I'm going to take the top equation times something that will make the x's cancel. And that something would be a -2. Because if I had a -2 right here, then my x's would cancel. So I draw an arrow, and I'm going to put times -2. So the top equation becomes -2x minus 4y equals -20. And you have to make sure you take everything times -2. And you're probably wondering why I wrote -20. That should be a -10. Okay, I make mistakes too. Bottom equation, I'm not going to take it times anything. That should stay the same. 2x plus 6y equals 12. Okay, pause it if you need to. Okay, so now I should be able to add these two equations together and something should cancel. See, that's a -2x and a positive 2x. And let's see if they cancel. So add them up. Gone. Add them up. 2y equals. Add them up. 2. Alright, now I'm down to a baby pre-algebra equation. Divide by 2. Y equals 1. So we're halfway there. Our y value is 1. Okay, we now need to plug the 1 back into one of the two equations, but it is a y value because it's y equals 1. So your choice, do you want to plug it into the top equation or the bottom equation? And it doesn't make a difference whatsoever. So I'm going to go ahead and pick the top equation since the numbers are smaller. So I'm going to take this original equation and come right down here and say x plus 2 times 1, because our y value is 1, is 2 equals 5. And once again, we got a baby pre-algebra equation. Subtract the 2 over, x equals 3, and voila, 3, 1. Let's do the next one. Same thing. It shouldn't take us very long. We want to get something to cancel. Well, if we took the top equation times 2, we'd have a 4 right here, and 4 minus 4, that would make my y's cancel. But even easier, we can take the top equation times -1. And if we put a negative, or top equation times -1, that'll cause that to be a negative, and then our y's or our x's would cancel. So I'm going to rewrite the top equation. Ready? -x minus 2y equals -4. Bottom equation stays the same. So we're actually canceling the x's this time. That's the easiest way, I think, to do it. So the x's cancel. -6y equals 12. Divide by -6. Our y value equals -2. So we're halfway there. -2 is our y value. We're going to plug that back into one of the two original equations. I'm going to pick the, you know what, since I have a negative, I'm actually going to put it in the bottom equation because that negative and that negative makes it positive. So we get x, -4 times -2 would become positive 8 equals 16, and subtract the 8 over makes it 8. Okay, so 8, -2. Now, if you happen to want to choose the top equation, you could totally do it. If you plug -2 right there, look what happens. You'd have x minus 4 equals 4. And when you add that over there to that side, it becomes x equals 8. So it doesn't matter which equation you choose, you still get the same answer no matter what. Okay, so there's a basic couple of elimination problems.